Hi, welcome to the presentation, Community Antenna TV System. Community Antenna TV System, it is called as an cable TV. Nowadays, we are calling it as cable TV. Originally, it is called as Community Antenna TV Systems. It is specifically for distributing the television programs through the RF signals. These RF signals are transmitted through the coaxial cables or by digital light pulses through the hybrid fiber coaxial networks. In To receive the signals that was RF signals that was passed through the cables, we are having a receiver at a location. These cable lines will be distributed on the local peoples, and these cable will bring signals to their customers' own service, or by doing an service drop, or by using an overhead cable, or sometimes it as an underground cable. The community antenna company will provide a distribution box at, at the building's exterior, which has a signal that is projected towards the walls and have jackets which was placed in different rooms to which the televisions or the connected. This is the standard network cable TV system. There will, if you see, there will be an if you see, there will be video signals, and the control signals will be there. These are the cables, and it is an optical cable which has an electrical line, and here an amplifier, a filter, and an overhead jack. The video and control signals will be passed on here. Based on the signals, the overhead jack will filter out the signals and provide to the distributors. So each channel, each program will occupy an 6 megahertz channel, and the spectrum of that will be comprised between 50 to 550 megahertz, which can accommodate 80 channels per coaxial cable. Is the layout, the brief introduction of the layout. The network has common head stations which provide the signals to the individual services through the distribution boxes, which the signals can be passed on through the optical fibers. These optical fiber network can be connected to the 500 ohms. One fiber node can be used to convert a downstream into an head electrical signal. Upstream consists of converting an electrical signal into an optical signal. So downstream, it is used to convert an optical signal to electrical signal, upstream from electrical signal to optical signal. And in head station, head station which is used to access the video servers, and it is serving as an internet via backbone network, and it is a main part which distributes the programs to the all locally connected channels. The signals are bidirectional signals. It can be obtained from here and also here. Downstream from the head station to the users is also possible, and upstream to the head stations is also possible. This is the general layout. This is wireless cable TV system. In wireless cable TV system, all those things, there is no optical cable or coaxial cable to connect with it. All those signals will be connected to the hybrid fiber wireless systems. Here, digital video will be sent to the door cup and over the optical fiber, and the local coaxial cable will be replaced by the local wireless systems. These specifies the range of the wireless systems: 2 GHz to 3 GHz for 40 km, 33 to 6 MHz channels for 25 kilometers, so on. So based on this distance, the number that is occupying frequency will vary. The wireless portion of the network is extended as Wi-Fi. We shortly called it as Wi-Fi, through which the frequency, if the frequency is matched, the parameters can be shared. Here also the uplink and downlink both are possible. These systems are less expensive than the normal cable systems because there is no wire need in that, but it is highly prone to noise compared to cabled wireless systems, cabled wired systems. It is in CTAT. We have three layer of networks, and decomposition it is different for downstream and upstream. They are using the common frequencies of 5 to 750 megahertz, and if upstream and downstream will occupy the same frequency bands. Data over cable service interface specification. These are specifications which is a common standard which represents data over cable service interface specification. It is actually developed by multimedia communication networking systems. The goal of this data over service interface specification is to transmit and whatever we want to transmit between an user cable modem and the cable modem transmission system at the higher end. If there is a transparently transmit of data through the cable modem. Here, the main working it is the frames are divided into mini slots, and the user make a request of the slot to be availed. So through an CMTS, then that will grant some minimum number of slots in that particular frame. Then it uses an modem ID and the bandwidth requested. Then the slots will be once free. All the grants will be carried out through the downstream frame. If one or two cable modem requests at the same time, the collision will occur. So to learn about the collision, we have the transmission techniques that's like collision avoidance and collision acceptance. All these things can be implemented in this particular part. If two or more cable process the request at the same time. So the modems it is modulator and demodulator. It have and random time to send the slots and pick up the slots. So these can be specified by using the ATM sets. So this is video on demand. It is also known as video dial tone. Some subscribers they demand for videos instead of going for data or image. So video it is a larger collection of programs. So in that cases we need set-top boxes at the receiver end. So the head transport will request for an MPG that is video digital stream over the channel, and after that will be decompressed at the receiver end. So this generates an signal at the TV set. TV set in the sense in the set-top box set. For accessing that internet, we need 3 Mbps of upstream and 38 Mbps of downstream. And at a time, 10 subscribers can be used to share a resource. And that resource sharing will be based on the fees on monthly or yearly basis. Thank you.